Hi everyone, this is Bhairab Samanta and welcome to your mathematics class Mojar Ganit. Today we will discuss how to solve the problem of heights and distance in trigonometry. Actually, we have a series of trigonometric classes, so you may watch those classes so that you will have a clear idea about the basics of trigonometry. So today we will discuss some particular types of problem which are commonly known as height and distance problem. So let's jump to our screen and we will discuss how to solve that kind of problem. So let's start. So here what will you find? Actually in every problem, obviously on the topic of heights and distance, in every problem you will find a story which will convert into a story of a right angle triangle only. So in every problem there will be a right angle triangle. Actually the real story will convert into a story of a right angle triangle. Obviously, since in a right angle triangle one angle is a right angle and the another two, if we know about one of the another two, then we will find the third one. So here you will find that one of the angles of the unknown angles, it may be given in the problem, and here among the three sides there will be a known side. Okay, there will be a known side in our problem, and in most of the problems we have to find one side among the three sides. So what we will have given one angle theta and one side. Okay, then we have to find another side. In some of the problems you will be given two sides and then you have to find the angles among the two unknown angles, because one angle is already known, that is 90 degree. So here you also have to remember two terms. One is angle of elevation and the another is angle of depression. Okay, so what is the angle of elevation? When somebody from C looks towards the point A, then the line CA makes an angle theta with the horizontal level BC. Then this angle theta is called the angle of elevation. And when somebody at A looks towards the point C through AC, then the line AC makes an angle alpha with the horizontal level. Here the horizontal level is this level. So in that case the angle alpha is called the angle of depression. Actually you may find the angle of depression, if the angle of depression is alpha, then you also find this angle is also alpha by the property of alternate interior angles. Actually both the horizontal levels are parallel, that's why we don't face any problem, but we need to know clearly what is angle of elevation and what is angle of depression. Now we will go through some examples, particular examples, so that we can understand in a better way that how to solve this kind of problem. So let's go through some examples. We will take some example from our NCERT book. So let's jump into our examples. Here we will take our first problem. You may find it in your screen. A circus artist is climbing a 20-meter long rope which is tightly stretched and tied from the top of a vertical pole to the ground. Find the height of the pole if the angle made by the rope with the ground level is 30 degrees. So here actually there is a pole and a rope is tightly stretched from the top to a point on the ground level. Okay, then this is the ground level which turns into a right angle triangle. So actually the story of every problem will turn into a story of a right angle triangle. So here if we consider this right angle triangle as ABC, where the angle C is right angle. Here AB is the rope, so the length of AB is 20 meter, and the rope makes an angle 30 degree with the ground level. So this angle, that is angle ABC, is 30 degree, and we have to find the height of the pole, that is AC is our pole, so we have to find the length of AC. Okay, so now we will understand how to think this kind of problem. So here we have a given side and we have a question about a side, and we have an angle which is known. So here if we consider these two sides AB and AC, why only AB and AC and not the side BC? Actually AB is known and AC is our question, so we have considered these two sides, and here our considered angle is angle ABC, which is 30 degree. So with respect to that angle, here AC is our perpendicular and AB, obviously AB is always hypotenuse. So here we have hypotenuse and perpendicular. So we will think about what ratio we should use so that we can solve the problem. Here with hypotenuse and perpendicular, these with these two ratio we have a trigonometric ratio which is sine theta. So we use sine of 30 degree, that is equals to perpendicular by hypotenuse. Actually you may also use the cosec theta, because cosec theta is equals to hypotenuse by perpendicular, but we will be more comfortable with sine. We will consider sine 30 degree equals to perpendicular by hypotenuse. So here perpendicular is AC and hypotenuse is AB. Also length of AB is 20 meter, which is given, so AC by 20. Actually sine 30 degree, we have sine 30 degree is equals to half. So sine 30 degree is equals to half, and here AC by 20. So solving this, 2 AC, 2 into AC equals to 20, which gives AC equals to 20 by 2, that is 10. So we have the side AC is of length 10 meter. So what we have learned, we will use two sides. Obviously, one is known and another is our question, and we will use the angle which is given. Then we will use that ratio, that trigonometric ratios which relates our considered two sides. Okay, so now we will discuss another problem in which we will find some another side. Okay, so now we will find the problem, another problem in your scale. Here a kite is flying at a height of 60 meters above the ground. The string attached to the kite is temporarily tied to a point on the ground. The inclination of the string with the ground is 60 degree. Find the length of the string assuming that there is no slack in the string. Actually, what happens? Actually, when you fly a kite, the string, practically the string looks like this one. Okay, here is your kite. So actually there is a slack always, but here for our problem solving purpose we will consider that there is no slack. Okay, okay, so here this problem also, the story of this problem also turns into a story of a right angle triangle. Okay, here let us consider a right angle triangle, let's say ABC, and BC is the string, and obviously the kite is at the point A, and the string is temporarily attached to the point B on the ground, and the angle ABC is given as 60 degree. Also the height of the kite, that is the height of A from C, is given 60 meter, and we have to find the length of the string, that is the length of the side AB. Here also we will use the side AB and AC. Actually here the same, actually it is also the problem of the same kind. Here AB is hypotenuse and AC is perpendicular. So sine of 60 degree equals to perpendicular by hypotenuse, and the value of sine 60 degree is root 3 by 2, and the value of perpendicular is 60, and h is our question. So here it implies root 3h equals to 2 into 60, and which implies h equals to 2 into 60 divided by root 3. So we will simplify this here. So h equals to 2 into 60 divided by root 3. Here if we divide 60 by root 3, then we will get 20 root 3. Actually 20 into 3, that is 60, and 3 can be written as root 3 into root 3. 1 root 3 is cancelled out. So h is equals to 2 into 20, that is 40 root 3. So length of that string is 40 root 3 meter. Okay, so then we will write the answer as the length of the string. uh, One thing, you always should write the answer separately at the end of the problem. Okay, so the length of the string, length of the string is 40 root 3 meter. So you will also use the value of root 3 as an approximation value, or you may find that the value of root 3 is given in your question, so you can use that value also. Okay, or otherwise you may leave it at 40 root 3, or you may use root 3 equals to 1.73 as an approximation. Okay, so what we have learned, we will use those two sides, one of which is our known side actually, whose value is given in the problem, and the another one is our question, and we will use that trigonometric ratio which is related to these two sides. Okay, so I hope you understand, and if you have any doubt, so you may ask in the comment, and you can repeatedly watch the class. If you have slight doubt, then I think you will have a clear idea how to solve this kind of problem. Okay, so that's it for today. We will see in the next class. Till then, goodbye and have a nice day.